let's just move on further towards representing the irrational numbers on the number line. As we know that how we can represent a particular rational number on the real number line, but now or from now on we will discuss about how we can represent the irrational numbers on the number line. So let's just start with the very first irrational number. Let us suppose I'm talking about square root 2. So the value of the square root 2 is like 1.4142135623. So it is such kind of a number which is actually a non-repeating and a non-terminating one. What is the meaning of non-repeating and non-terminating? As we can see from the value root 2, this particular value is nothing but a non-terminating one. As it so goes on, the value of root 2 is nothing but 1.4142135623 and so goes on. It is not terminating at all. So that's why it is a non-terminating number, and it is a non-repeating one. Why it is a non-repeating one? Because no number over here or any number doesn't repeat over here or doesn't shows any particular kind of a repetitive pattern. So any such number which is of the kind non-repeating and non-terminating one, it is quite impossible for us to plot it on a number line. So let us suppose I am talking about the number line and I am taking the values, let us suppose 2.664, 2.665 and 2.666. So let us suppose I just want to plot any particular irrational number that is lying in between these two values, that is 2.665 and 2.666. So in order to plot any particular value that is lying in between 2.665, 2.666, definitely I have to magnify the values, because we know that in between any two rational numbers there are infinitely many rational numbers. The same concept goes on for the irrational numbers as well. As we know that in between any two numbers there are infinitely many irrational numbers. So it means that after magnifying 2.665, 2.666, we have to find out the particular values which are, let us suppose, of this kind, which are non-repeating and non-terminating ones. So it is kind of an impossible task for us to plot such kind of numbers on the number line without the help of magnifying it. So let's just start, or let just discuss about how we can able to plot such kind of a numbers in an easy manner, because from this particular thing we are very much clear that it is quite impossible for us without the help of this magnifying glass that we can plot such kind of numbers on the number line. So let's just move on further towards the easiest way through which we can plot such kind of numbers on the number line. So let's just move on further. We'll talk about a very famous concept which is called as a Pythagoras theorem. A Pythagoras theorem says that, let us suppose we are talking about any particular triangle, and it is a special kind of a right angle triangle which is right angled at the angle A. It is right angled at the angle A. So we are talking about making a 90-degree angle at the angle A. So Pythagoras theorem says that for any right angled triangle, hypotenuse square is nothing but is equal to perpendicular square plus base square. So this is a very important concept to the help of which we can able to plot any irrational number on the number line. So let us suppose I am talking about the Pythagoras theorem. The Pythagoras theorem says that, let us suppose we are talking about any right angle triangle which is right angled at the point A. So we have hypotenuse over here. This OB is nothing but called as the hypotenuse. This AB is nothing but called as the perpendicular, and this OA is nothing but called as base. So let's suppose I'll mention over here, this is nothing but called as the base of this particular triangle, and this AB is nothing but called as the perpendicular. This is nothing but the perpendicular which we can represent as a capital of P. We can represent the base as capital of B, and let us suppose I'm talking about this particular OB. Let us suppose this is nothing but my hypotenuse. and we are representing it by capital of H. So there is a relation. There is a relation in between these three things, that is H, B and P, is that the hypotenuse square is nothing but perpendicular square plus base square. This is nothing but the Pythagoras theorem, which says that hypotenuse square is nothing but is equal to sum of the squares of the other two sides. So from this particular Pythagoras theorem, we can say that what is hypotenuse? What is hypotenuse over here? Hypotenuse is nothing but OB. So OB's square is nothing but is equal to P square. What is perpendicular over here? Perpendicular is nothing but AB. So this is AB square plus base square. What is base over here? Base is nothing but OA. So this is OA's square. So OB square is equal to AB square plus OA square. This is nothing but the Pythagoras theorem. Now we have to plot square root 2 on the number line. So how we can plot square root 2 on the number line? Let us suppose I'll talk about the base as of 1 unit. Let us suppose I'm talking about the base OA as 1 centimeter. So let us suppose I am taking OA as 1 centimeter, and even I am taking the OB, or let us suppose I'm talking about AB. Let us suppose I'm talking about AB. I am taking AB or the perpendicular as 1 centimeter as well. So here I'm talking about the base and the perpendicular. I am supposing that the base is nothing but 1 centimeter and the perpendicular is also nothing but 1 centimeter. Let us suppose I'm supposing it. So if I'll suppose it that if OA is 1 centimeter and AB is 1 centimeter, so with the help of this particular Pythagoras theorem, with the help of this particular Pythagoras result or the Pythagoras theorem, we can say that Pythagoras theorem. So with the help of this Pythagoras theorem, we can say that if the value of OA is nothing but 1 centimeter, substitute all the values of OA and AB in this particular result. So let us suppose I'm calling this equation as nothing but 1, and I am taking these two as equation number 2. So let us suppose I'll substitute equation number 2 in the equation number 1. So substitute equation number 2 in 1. If I'll substitute equation number 2 in 1, then the value will be OB's square is nothing but is equal to AB square. What is the value of AB? AB is nothing but 1 centimeter, means 1 square, plus OA is nothing but 1. So this is nothing but 1 square. So OB's square is nothing but 1 square means 1 plus 1 square means 1. So 1 plus 1 is nothing but 2. So it means that the OB's square is nothing but is equal to 2, which means OB is nothing but square root 2 centimeters. So this will be nothing but square root 2 centimeter. It means that the hypotenuse over here is nothing but a square root 2 centimeter. So it means that if we are taking the base or the perpendicular of any particular right angle triangle as 1 and 1, so its hypotenuse is nothing but square root of 2. So with the help of this Pythagoras theorem, with the help of this particular representation of a right angle triangle, we will now plot square root 2 on the number line. So let's see how.